InterFET, the low-noise JFET specialist. Thank you for taking a few minutes for this presentation of InterFET die geometries. Our hope is that it gives you insight into both the flexibilities of JFET performance and the capabilities InterFET has for tailoring die designs to best meet existing and future analog demands. Geometry is where it all begins when it comes to JFETs. That's because the geometry of the die sets the fundamental electrical parameters: breakdown voltage, leakage current, capacitance, noise, and gain. Since JFETs are all we do, we own the entire process, from die design to wafer fabrication to packaging. That means when a customer needs a very specific set of parameters, we can deliver it. Take breakdown voltage and gate current leakage. Higher breakdown generally means lower leakage current, which is critical in sensitive medical and instrumentation applications. Or look at cutoff voltage and saturation current. Adjusting these changes how much current the device can handle and where it pinches off. Small geometries give you low input capacitance and high frequency response, while larger die design maximizes gain and minimizes noise. That's why our IF3601 series is famous as the industry's lowest noise JFET, while parts like the IF4500 deliver low capacitance and high transconductance for power-sensitive designs. The bottom line is that JFET design is a series of intentional design choices, and InterFET's broad geometry portfolio lets engineers optimize instead of compromise. Throughout this video, we'll dive deeper into the attributes of each geometry InterFET offers. We've included this physical comparison simply to give you a feel for the variation in size of each geometry. As die area increases, JFET performance shifts predictably, from ultra-low leakage current and capacitance toward higher transconductance, current capability, and reduced noise. JFETs are all we do, and that focus matters. We own the entire process, starting with die geometry through wafer fabrication, testing, and packaging. Because geometry is under our control, we're not limited to off-the-shelf compromises. Instead, we can intentionally design and tune devices to meet specific electrical requirements, whether that's leakage current, noise, gain, or voltage handling. Selecting JFETs for your design is all about understanding the relationship between key parameters. That you'll see throughout this video. By offering 15 geometries that give rise to thousands of part numbers, we enable design engineers to optimize for their exact needs. For high-frequency, high-impedance applications, small geometry JFETs provide low input capacitance and strong frequency response. These are ideal for circuits where speed and bandwidth matter most. For low-noise applications, larger geometry devices reduce internal noise, making them perfect for sensitive audio or instrumentation circuits. Our IF3601, for example, is the industry's benchmark for ultra-low noise. There are also mid-level options that balance gain, impedance, and noise, such as our IF140 and IF1320 families, providing flexibility depending on the design priorities. Beyond our standard catalog, we support customer-specific screening and selection. If your application calls for parameter limits or test conditions that are tighter or different than our published data book specs, which of course are based on defined standard test conditions, we can test your conditions and supply JFETs that meet those requirements. For example, breakdown voltage, gate leakage current, cutoff voltage, and saturation current. This allows customers with unique operating points to receive devices that are verified for their exact use case, rather than relying solely on datasheet conditions. The takeaway is this: JFETs aren't a one-size-fits-all component. They're a toolkit. And with InterFET's portfolio, designers can select the right device for your specific application, unlocking performance others simply can't match. The N0001 geometry is one of InterFET's original platforms and remains a benchmark for ultra-low leakage current performance. It's optimized for extremely high input impedance and long-term stability, making it ideal for electrometer inputs, precision instrumentation, and legacy aerospace and medical designs. Many foundational part numbers trace directly back to this geometry, underscoring its reliability and proven track record. The N0014 geometry is InterFET's foundational low-noise design. It offers excellent linearity, strong gain, and balanced capacitance, making it a versatile choice for precision amplifiers and audio front ends. With both X and L variants available, designers can trade higher transconductance for higher breakdown voltage depending upon their application needs. The N0014 EU geometry builds on the N0014 platform, but is optimized for compact, high-frequency, low-current leakage applications. Integrated back-to-back diodes provide clamping and additional gate protection while maintaining excellent signal integrity. Its flip chip compatibility and low capacitance make it especially well suited for modern hybrid and wideband analog front ends. The N0016 geometry family is InterFET's most widely used general-purpose JFET platform. It strikes an exceptional balance between low noise, moderate capacitance, and broad bias flexibility. With S and H variants available, this geometry supports everything from precision audio amplification to regulators, current limiters, and legacy replacements, which is why so many industry standard part numbers are built on it. The N0026 family represents a mid-sized geometry optimized for wideband, low noise amplification, and voltage control resistance applications. The S variant emphasizes higher voltage handling and stability, while the L variant prioritizes higher gain and current capability. This makes N0026 a flexible choice for sensor interfaces, instrumentation, and analog signal conditioning. The N0030 geometry is defined by exceptionally low input capacitance and ultra-low gate leakage. These characteristics make it ideal for high-frequency, wideband amplifiers and charge-sensitive front ends where signal integrity is critical. Its wide operating range and strong linearity give designers excellent flexibility in both discrete and integrated analog designs. The N0032 geometry adds higher voltage robustness while maintaining low noise and low capacitance. With a 60-volt breakdown rating, it supports wide signal swings and high dynamic range. This makes it a strong general-purpose choice for precision amplifiers and instrumentation circuits that require both stability and headroom. The N0042 geometry is engineered for extreme voltage environments, with breakdown ratings reaching hundreds of volts. Despite this high voltage capability, it maintains low input capacitance and stable high-frequency performance. It's widely used in high-voltage analog stages, sensor interfaces, and protection circuits where reliability is critical. The N0072 geometry is optimized for low-noise, high-gain amplifications. The S variant offers higher voltage robustness, while the L variant delivers significantly higher transconductance for maximum gain. This makes N0072 especially attractive for audio, instrumentation, and match pair applications where noise performance is paramount. The N132 geometry family delivers exceptionally low noise and very high transconductance. With H, S, and L variants available, designers can scale between breakdown voltage, gain, and capacitance without changing the underlying die structure. This makes N132 ideal for precision audio, match pairs, and wideband low distortion amplification. The N450 family moves into large area die designs focused on ultra-low noise and high gain. The H variant supports higher voltages, while the L variant delivers extremely high transconductance and the lowest noise in the family. These devices are commonly used in sensitive audio and instrumentation front ends where signal fidelity is everything. The N903 geometry bridges the gap between mid-sized devices and InterFET's flagship geometries. It delivers very high transconductance, extremely low noise, and balanced capacitance. This makes it an excellent choice for high gain, low distortion amplifiers, and precision sensor interfaces that need performance without excessive loading. The N3600 geometry represents the pinnacle of InterFET's JFET design capability. With unmatched transconductance and the lowest noise in the portfolio, it's purpose-built for large capacitance detector preamps and ultra-sensitive front ends. Its massive die area allows it to drive heavy loads while maintaining exceptional stability and signal integrity. InterFET also offers P-channel geometries starting with a P0032. This general-purpose P-channel JFET supports low noise, high input impedance, and robust voltage handling. It's well suited for differential amplifiers and analog switching. The P0099 geometry advances P-channel performance with higher transconductance, lower noise, and greater current capability. It enables high performance in precision analog and audio circuits. For designers building fully symmetrical signal paths, this geometry provides a powerful tool. The key takeaway is simple. JFETs are not one-size-fits-all components. They're a toolkit of intentional design choices, and geometry is where those choices begin. By offering one of the industry's broadest geometry portfolios, InterFET gives designers the freedom to optimize performance instead of settling for compromise. What sets InterFET apart from all other manufacturers is our ability to deliver customer-exclusive JFET solutions through customer-specific screening and selection. Beyond our standard catalog, if your application requires parameter limits or test conditions that are tighter or different than our published databook specifications, again, which are based on defined standard test conditions, we can test to your conditions and supply JFETs that meet them, such as breakdown voltage, gate leakage current, cutoff voltage, and saturation current. So your devices are verified for your exact operating point rather than inferred from datasheet conditions. If you enjoyed this video, give it a thumbs up and subscribe for more expert insights into JFETs, analog design, and low-power electronics. Hit the bell icon so you never miss an update from InterFET. Got questions or ideas for future videos? Drop them in the comments. We'd love to hear from you. Interested in using JFETs in your next project? Reach out to us directly through our website or the link in the description to speak with our team of experts. Stay connected, stay curious, and keep innovating with InterFET.